Okay, I'm going to continue task 7.4 discussion, starting on this page. Another set of triangles here, and we have the markings, 1, 2, and 3 tick marks on each triangle. So we have, basically the tick marks say that the sides are congruent. So we actually have 3 pairs of sides congruent. So what we're questioning here is, does the rule side, side, side give us congruent triangles every single time? And the answer is yes. Let's take a look. I have my little triangle again. I'm going to translate point C to coordinate with point R. Now, how do I know that those two need to go together? One way you can look at this, if you look at point C, I like to look at the tick marks. Point C is in between the side with 3 tick marks and the side with 1 tick mark. So if I go over here, the side with 3 tick marks is there, the side with 1 tick mark is there, the angle in between is angle R, so C and R should correspond to each other. Now technically at this point we don't know that C and R are congruent, but this process will help us validate that they actually are. So I'm going to match up C and R. Again, you can take any pair of corresponding angles that you want. These are just the ones I'm going to choose. So point C matching up to point R goes right there. Notice how I didn't rotate or anything yet? So I'm just going to translate. I'm going to rotate. I'm actually going to go counterclockwise. That makes sense. About point C and R right here until this side, CB, corresponds with, let's see, CB needs to correspond with RQ. So CB, if we remember where that is, CB has a single tick mark. That's this side. Let's be careful about that. CB, this side, needs to correspond with QR. So here I go. I'm going to match up C and R. Then I'm going to rotate counterclockwise. I'm going to keep going. Not stop there. In fact, if I stop there, it doesn't match. You can see the tick marks don't even match. So I'm going to keep going. C to B, C to B, or CB to Q. Just like that. Now you can look, my tick mark from here matches my tick mark from there. Segment CB matches segment RQ. And then I'm going to reflect. I'm going to reflect my triangle over RQ. Down that way. I've lost my markings, but we can see that the triangle fits in there perfectly. Now if you're not using a small triangle like I am or patty paper to do this, that's okay. You may even be able to just visualize this in your head, or just to track the kind of movements that you would need to get things match up. You don't always have to have an extra piece of paper to work with. So basically this one works. So the rule side, side, side is a valid shortcut rule. So over the last few problems, we have these experiments, these justifications we've worked with. We basically have some that worked and some didn't. So what criteria worked and what didn't? Well, we started with angle, side, angle. We showed that that worked. We had a side, angle, side problem. That worked. And side, side, side. That worked. Okay, so there's 3 that work and will give us shortcuts. We did explore 2 that did not work. So angle, angle, side, and side, side, angle, neither of those work. So when you're trying to prove that triangles are congruent, which is something you'll have to do in your homework, which is this, you're going to try to use or look at the markings that you're given and decide if you have either of these situations set up, or maybe you have some of these situations set up, and based on what you're given, it may work, it may not work. Okay? Even if the triangles look congruent or appear congruent on the page, it doesn't mean that they necessarily are. You have to use one of these rules to kind of prove it. Alright, there's a couple more that really we didn't cover in our exploration, so we're just going to talk through those in problems 11 and 12. Let's say you wanted to add another combination of these letters. How about angle, angle, side? So that would be an angle, the very next angle, walking around the triangle, and then the very next side. So 2 angles and then the following side. What do you think? Should we add that or not? So here's what I'm thinking about. If we have 2 angles of a triangle are congruent, then I think the third pair of angles must also be congruent. You try to draw a triangle where you know two angles to be congruent for the where you know two angles that are congruent in each pair of triangles, and then you try to draw all the different kind of triangles you can out of that. I think what you'll find out is there's only one possible triangle that you can get out of that scenario. And I'm going to go back to page 31, problem 5. When I had an angle here, two angles here, and a side, if I extended these lines, there's only one place that they can meet. There's only one triangle that is going to create. So it's a very similar thing if you do this. Two angles in the very next side. If you tried to draw that out, you would see there's only one resulting triangle that you're going to get. The other thing you can think about, and I should have drawn a triangle here, but let's say we had this angle, and then this side. Those are not meant to be point names. Those are just angle, side markings. What if we knew these two angles were the same, and then that third angle had to be the same? Based on what I was just talking about a minute ago, there's only one way to draw that triangle. Then we could also just look at, if we said the very next angle, we would have angle, side, angle, which I wrote this way. And this, just this part of it, angle, side, angle, already is one of our included theorems that work, or reasons for triangles to be congruent. So angle, side, angle works, which shows that angle, side also has to work. Number 12, there's another one actually called hypotenuse leg. Could we do that one? The hypotenuse leg theorem is sometimes called RHL, where R stands for a right angle. A hypotenuse and a leg are like these parts of a right triangle. Even though it's only two sides, we need three parts for sure. But since we know it's a right triangle, technically we know that these two angles have to be congruent. So only for right angles, or right triangles, this works. But so basically it's saying if we have an angle and then two sides, or two sides and an angle, basically puts us back at this side angle option. But the angle, if it's 90 degrees, then there are some special properties with this. In a right triangle, the unknown third side that we have in the bottom, like on these pictures, you could actually calculate what that third side is using the Pythagorean theorem, right? So if we calculate this side, if we had side measures, side lengths, then we would actually end up with three sides that we know. So in a right triangle, if you are given two sides, you can calculate the third side, and then you can compare all three sides to another triangle to see if they're congruent. So side angle then becomes not just side angle, but the third side is also known. So if we put a little S here, that gives us, as a piece of it, side. Okay? Actually, technically, you could also, if you put the S on the other end of this, like I drew it here, that would also leave us with just side angle side, which is also a method that we're allowed to use. So either way, you will have something that'll work on that. Remember, it is only for right triangles. Okay, I hope that helps. You can revisit any of this that you need to, or perhaps we could even find some additional YouTube videos that would help us understand these extra conditions. So please give your homework a try. Hopefully you understand this enough to be able to do that, and we're going to practice this over the next, today and also our next day of class. Thanks.